guess it did coincide with the, for instance, I'm trying to kind of show you our star being in the plane of the Milky Way again. Okay, so that was kind of edge on. This is kind of face on again. So I don't know if you remember, but we said that it takes, and I think this might have been a test on your question, or question on your test, that it takes our sun based upon its location from the center of our galaxy. It takes our sun 230 million years to complete one circle. And all the while, it's kind of bobbing up and down, okay, with its neighbors there. Was it, I think it might have been in my other class where somebody said they knew she was taking astronomy, and they're like, hey, you got to see this. So basically, I don't know if I can explain this. Basically, if we picture the sun, kind of, I'll go ahead and put like that. Okay, that's its movement here. And what if you picture the planets orbiting kind of like that? I don't know if this is going to make sense, but basically, as the sun moves around the center of our galaxy and the planets move, we kind of make this sort of kind of corkscrew in space. Isn't that kind of cool? Yeah. It's true. Okay. This actually is a way to gauge the amount of mass that is from your location to the center of mass, like from our sun's location to the center of our galaxy, relative to how far we are from the galaxy, okay, and how fast we're moving. So those are three unknowns, and if we know two of those three unknowns, we can get to the other one. So say we know the radius and the velocity, we can get to the mass that must be contained within our orbit. Okay. So another topic is this thing, I think it's almost like star recycling, but it's galactic recycling. Okay? And it basically kind of starts out as two dust clouds. The hydrogen cloud is hotter than the molecular cloud. Okay? And then from the molecular cloud, we can get stars to be born. This is the Eagle Nebula, little stars being born. When stars are main sequence, they are converting hydrogen into helium in their cores. Okay? Stars eventually die. They may give their material up as planetary nebula, and or if they're massive enough, they may give their material up during a supernova explosion. Okay? But what can happen then is that material can be recycled. Thus the story continues. So part of new stars being born is kind of needs a little bit of a push. And so actually kind of this blowing, this movement of material can help start the birthing process. Planetary nebula, part of the recycling process. Okay, and this is kind of, looks like something edible. But like this caption says, this is showing you kind of, there's an explosion under that pile of gas. And recycling material that can be used for new stars to be born is the emphasis of this part of this lecture. I'm trying to think what you need to know. Doesn't this seem like stuff we've talked about? These are supernova remnants, okay? Stuff that can be used back recycled back into stars. This topic is kind of talking about what you're looking at is the plane of the galaxy is coming out at you, and these are kind of like looks like a pimple or something, but basically material can kind of float above the plane of the disk. And you see kind of a cooling process, and it can float back down, and it can go ahead and galactic recycling. So a few slides ago, when I said the hydrogen was hotter than the molecular clouds. That's kind of the order of things. Hot hydrogen gas, when it cools down, can go ahead and form into compounds. There's Orion. So these are the belt stars of Orion. And these, to me, kind of come up on the horizon. 1, 2, 3, like that. And then these are the kind of the corners of his toga. And in his sword region, hanging down from his belt, is a nebula. And I said, that's where stars are being born. And it is where stars are being born. All within our galaxy. Eagle Nebula, stars are being born. This caption kind of talks about as a star comes alive and it begins its stellar wind, kind of like our solar wind, it can blow away stuff so that no new stars can be born right next to it. It could still have a companion, but it kind of clears its area. So what we saw was this. We'll have to decide what I want to put on your test. But do you see where galactic recycling to me is kind of like stellar recycling? Like, let's take a 10-minute break, and we won't be here the full segment for the next time, but take a little break, and then we'll have a short segment, just finish these slides, and then we'll go home, okay? It's funny, because I like, okay, like, you're really going to say no, right? No. You could.